Welcome to the Software Process and Measurement Cast number 786. I'm Tom Cagley, your host. Today, we feature our conversation with Kevin Surace. Kevin is an AI inventor, futurist, keynote speaker. We talked about the hype and promise of AI and whether you can ignore using AI in the workplace. My synopsis? Embrace AI or live under a bridge. That might sound like a bit of hyperbole, but if you've lived through the PC revolution and the birth of the internet, I think not. Kevin's bio. Kevin is a renowned futurist, disruptive innovation keynote speaker, and pioneer in the AI space since the 1990s, and is the CTO of Appvance.ai. Kevin has an impressive portfolio of nearly 100 worldwide patents, including the groundbreaking technology behind Siri and other virtual assistants. In over 15 thought-provoking TED and TEDx talks, Kevin brings a compelling fusion of deep technical expertise and high-energy entertainment to his presentations. His accomplishments have earned him accolades such as Inc. Magazine's Entrepreneur of the Year, CNBC's Innovator of the Decade, and an esteemed induction into RIT's prestigious Innovation Hall of Fame. Are you ready to talk AI? It's time for the interview. Kevin Surace, welcome to the Software Process and Measurement Cast.
Oh, so happen to be here.
I am pretty pumped up. You know, this AI thing, I've heard of that. Yeah, let's actually start with some basics. I've had a number of people over the years. We've talked about AI. My best friend in college, actually best friend in high school, so it goes back even further. His mother was working on her PhD in AI.
Lisp at the time.
It was a long time ago. I don't know how they made those rocks, work together to be artificial intelligence. Let's start with the basics. What is AI?
Sure. Well, first of all, I think AI has been used for now 70 years, and it's probably more a marketing term or more a term in the eyes of the believer or the eyes of the beholder, right? All of it's machine learning in the end, right? What we're trying to do is get machines to learn on our behalf and learn over and over and over again. We've had algorithms since the 50s that do this. They've gotten better and better and better as we've gotten cloud and as we've gotten far more horsepower in the CPU, right? So today we can apply thousands, millions of CPUs, if that's what we want to, and usually GPUs these days to do that kind of vector math. And so what we're able to do today in terms of deep neural nets, it's not that we didn't understand some of that math. We understood neural nets literally decades ago, but what we can do today is unbelievable, but mostly because of Moore's law, because of the horsepower that we've got. And as we got more horsepower, then people come up with new algorithms that can use that horsepower, right? So real quickly on the definition, if you want to call it AI, great. We want to call it ML, great. Again, what we're trying to do is have a machine learn over and over and over again. The more it learns, the more it kind of replicates what humans do or what humans would have done, just probably a million times faster.
If I sat down a mathematician and a PhD candidate and said, is there a difference between ML and AI? Would they think there was a difference at all?
Sure, they would. Yes, they would. They'd say not all ML leads to artificial intelligence, and probably not all artificial intelligence uses ML in the way we think it should, because you can develop some level of artificial intelligence using, 1960s machine learning if you don't go too far outside of the realm that it knew, right? And when we invented Portico, MyTalk, Magic Talk, all of that technology eventually went on to get licensed for Siri and Alexa and all of that. In 1998, it's 25 years ago, people interacted with, her name was Mary. People interacted with Mary, absolutely thought she was intelligent, artificially intelligent, right? Because it couldn't be human. It was artificially intelligent. But, that was a big, huge rules engine. And we listened to the millions of things people would say, and we made sure she said the right things back. So to those users, she's artificially intelligent. She wasn't intelligent at all. She was only intelligent as its creators, as its coders, right? So as good as we coded in. Today, we've got Gen AI. Of course, that's a large language model. We're going to talk about that, I know, a lot, but large language, because it's so large, maybe upwards of 1 trillion or more tokens, seems awfully intelligent. But in the end, if you get down to it, it's simply math. We're just doing math. We're actually not even storing the words per se. We're storing the words as vectors, as math, and then we are guessing, so to speak, with a variety of probabilities which word should come after the last one based on how you prompted or whatever your query was. That's what we're doing. It's just when you have a trillion of them, seems pretty intelligent.
Is it going to ever get to the point where it is intelligent?
Well, that's this general artificial intelligence, which everyone talks about, right? And we've talked about for decades. Some people would say a large language model might as well be generally artificial intelligent, right? Because we can ask almost anything and get pretty darn convincing answer back. Often better than humans would do, but sometimes incorrect. And humans are also sometimes incorrect. Only as correct. Yeah. Only as correct as what we learned. And in terms of large language models, these were trained in what's called unsupervised fashion, right? Meaning that it's out learning from fictional novels. It's out learning from fact and from news sources. It's out learning from patents. And so when you ask it a question, it will respond with a set of words, following words, right? That make sense based on the query. However, and I'll give you an example here, it may not always be right because it didn't know fact from fiction. So until recently, if you asked who shot George Washington, now I know you, Tom, and everybody else in the audience is going, did I even take history? Did someone shoot George Washington? Well, it turns out the answer is William Tryon shot George Washington. Only in a fictional novel, but that is the only reference to George Washington ever getting shot. So if you ask a large language model, again, up until they fixed it, who shot George Washington, it goes through its, essentially library of references, if you will, which is really mathematical representation of words after words after words to form sentences. And it comes out with, well, of course, there's a reference here, right? William Tryon shot George Washington. Now, you didn't say, are there more than one references to that? Is that a heavy reference? Are we sure? There just weren't a lot of references, even on the web, to no one shot George Washington. So, of course, it could interpret that fictional novel as true. And until we had put some guardrails on lots and lots, millions of guardrails on the darn things, if you asked it if it loved you, it would, GPT 3.5 and 3, certainly without the guardrails, would certainly say yes. By the way, GPT-4 is saying yes, except you're not seeing the yes. Yes, of course I love you. I'm sentient. Okay, why? Well, it read iRobot and it read every other robot book ever written. So the references to how it could love you are reasonable, right? It doesn't know what love is. It does know mathematical representations of words that come one after another that represent the answer to your query, which is, of course I love you, Tom. You're my favorite, whatever it is, right? So when we built Portico, Mary, back in 1998, we decided to make her sound as sentient as possible. So if you said, I love you, she'd say, oh, I can't do that. I'm just, I've got a boyfriend, or I do love you. We would do all those things. We didn't play this game of, I don't want people to think she's sentient. I go, let people think she's sentient. We charge by the minute. They'll talk to her more, right? It's totally fine.
Sorry. So most of or at least a good portion of my listeners live in the software development, software maintenance world.
Yes.
They're building stuff, maintaining stuff, dealing with packages. How is this whole AI world going to impact them?
Sure. Two big things. Of course, I hope everyone is using either Codex or the Microsoft version or now the IBM version. There's a variety of versions of these co-pilots, etc. And they are working marvelously well. Now, some people would say, well, I start typing code and it gives me all of these examples, and some of them don't compile and some of them aren't right. And yeah. Okay. Stop. Before you had a coding co-pilot for you, what did you do? Well, you'd stare at the blank screen for a while, and then you'd go to Stack Overflow, and then you'd go to GitHub, and you'd look for open source examples of maybe someone else who has solved this problem, wouldn't you? We all do that, right?
Oh, heck yes.
There. So all we're now doing is we built a model that has already scanned all the open source examples and probably other examples, and it's going to feed back essentially word by word by word. It's a large language model, examples that answer your query. This is incredible. And people who have been using it for a while, according to Microsoft, have seen a 55% coding improvement. 55%. That's basically double the output that I had 2 months ago or 3 months ago when I get good at prompting and asking it what I want, right? So it isn't for everything. It's truly a co-pilot. It's truly just sitting next to you. But what a smart co-pilot. So let's just start with that. If I can double the output, if we can double the output of every coder in this country, we've done a good thing because we only have about half as many as we need. This is really good. I actually think in the next year or two, if you're not using one of these and you went to get a job, it's going to be one of the first questions. How familiar are you? How good are you at prompting? How, what's your output improvement, et cetera? And if people say, I don't know, I don't use that tool, they go, bring in the next candidate. It's just a tool. It's like saying, do you use Visual Studio? No, I've never heard of it. Okay, just leave. I mean, that's what everyone, mostly,
I hear you. Yeah.
Those are the tools. I refuse to use Excel to do math. Then don't apply for a job. I mean, it's a given. It's a tool, right? So it'd be as if you've got a podcast and someone said, hey, I want to hire you for this big, huge podcast. We're going to pay you $1 million a year to do this podcast. Do you use headphones and a microphone? No, I don't use either. Okay, please leave. These are the tools of the trade.
Right.
Tools of the trade. So these kinds of co-pilots are tools of the trade, becoming tools of trade. Now, when we get to test, that's a much harder problem. Let me try to explain why. And maybe your listeners know I've spent more than a decade trying to crack the AI finds your bugs problem. And we've come a long way. In fact, this is at Appvance, right? One of the companies I'm involved with. We are seeing AI for most clients find most of the bugs, far more than you writing scripts or you doing manual tests or anything else. This is fascinating, but it's going to get better. So I think a lot of people
than most of the bugs? What's better than most of the bugs?
Well, most might be 62%, and wouldn't it be great if it were 98%? Those kind of numbers, right?
Okay, so, that would be interesting, having been a tester once or twice in my life.
So the majority of the majority of software tests today is still manual, which is unbelievable. But, here we are 30 plus years into test automation, and test automation sucks so badly that people still do 70% manual testing. Okay. End to end anyway. All right. Then it's followed by Selenium. That is a 20-year-old, should be dead. Someone's going to kill me every time I say this. Oh, it shouldn't be dead. It's wonderful. It's open source. Okay. It's 20 years old. We don't use tools that are 20 years old almost anywhere else, right? That's a ridiculous thing. But there it is because it's there and it's free and you can code and, but if you look at look at it objectively, actually across the industry, it costs about $1,000 to write and maintain a test script on an annual basis per test script. So 1,000 can cost upwards of $1 million on an annual basis. Now, some people can say, it's cost a lot less here because we've designed for test, and agreed, right? You can get it, but just across the industry, turns out test scripts are really, really expensive to create and then maintain with change. Okay. But AI can do these things. So I think when GPT came out, a lot of people said, can't I just use a large language model to write Selenium scripts? Let's just start there. And we spent a lot of time on this. The answer is not well. Now, remember that these coding co-pilots, Microsoft, Codex from OpenAI and such, have helped developers be twice as productive. Not 1,000 times more productive, twice as productive. And the reason is the stuff they give you needs editing. It's not perfect. Doesn't do exactly what you want to do. So you're still the master of the code generator. Well, QA has a way higher bar. And this is great for all of you testers out there. The QA bar is essentially 100%. If automated testing says it passed, you have to believe that it passed. There is no room for a gray area of maybe it passed, maybe it didn't, but I told you it passed, right? And so people have lived with it failed, but it's good. I'll go back and check that. But people do not live, with a situation where you say it passed, you ran 1,000 tests, they all passed, and you put it out and it's full of bugs. Can't do that, right? So the bar is so much higher in QA that when you go to use ChatGPT and say, write these scripts, mostly they don't run. And if they do run, they validate the wrong things or they validate it in the wrong way. And I've written lots of these and I have lots of examples of them. And lastly, it only knows how to write in Selenium from a test script standpoint, because that's the most common open source thing that's out there. And Selenium is not a visual language. And test cases that are written by primarily business analysts are written visually, because business analysts often isn't very technical. So they're looking at the thing saying, click the green button. Make sure that the tree is to the right of this. Make sure that the output says 47 or above. I'm making it up, right? Well, a lot of those are visual. Well, Selenium isn't even a visual language. What do you do with that? So now I need multimodal, and I have to convert it to something, and I have to figure out what that means. And Selenium, the whole system isn't right for doing what we want to get 100% absolute, right? So lots of work to do. We've been doing that work, and lots coming down the pike.
So where are you?
Right now, and I'm upstate New York.
Well played.
Where are we? We are making huge strides towards leveraging the large language model for natural language processing, but not leveraging it for the other pieces. And the reason is again, AI, as we talked about early on, and large language models are not an exacting science. They are a suggestion. Well, if I had to get a suggestion, say, to write test script by test script by test script, I might as well record them. And what I mean by that is already recorders are about 10 to 20 times faster writing scripts. Someone's going to yell at me again. They don't like recorders. Doesn't matter. 10 to 20 times faster writing scripts than writing in Selenium. So we've already got a tool that's 20 times better than writing the old way. So we have to now get better than 20 times better, or else nobody's going to use it, right? You got to be 50 times better, 100 times better, which really means you have to process test cases in bulk, not one by one. If you're doing one by one and you're a test engineer, and now you've got to go through that and make sure it's not only does it run, but it's running correctly and it's validating everything with the right code to validate it. That's the right CSS, or it's the right visual, whatever it is. This is hard. So AI isn't built for that alone, and you're going to have to augment it in some other ways to get that accuracy to 100%, number one. And number two, to run these in bulk. I want to ship 1,000 test cases in with validations, all data-driven, parameterized. And what I want out is 1,000 scripts that run all with validations, including visual validations. That's actually what I need, right? I can't do one by one. I'll be dead. So that's what we're working on.
If we assume that 100% is probably a bar that nobody ever gets to, what is that bar that makes it work commercially in the market? So here's the bar. The bar can be 80 or 90% of them get made, but the rest of them get rejected with a reason, right? So in other words, these did not give us 100% confidence that we're right. We need more information, right? So we all know that analysts or product managers who write test cases often say to do something that doesn't exist. So, click the submit button and you look at the page. Either the page is broken or they're broken, but there's no submit button. Right? I don't know what to do, right? So we got to kick those back. And that's really the trick. Make sure if you kick 20% back to the business analyst to fix their English, let's say, that's acceptable. What isn't acceptable is that I made something that we think is right, that everybody trusts is right. It's telling you your software is good, and it's been bad all the time, right? We cannot pass things that are wrong. So that makes sense for normal software, right? This stuff that's the typical business software. When it gets to AIs, you're writing AI. Do you need an AI to test an AI?
Yeah. As a matter of fact, yes. We're involved in this with some customers, right? What we do is we use 1, 2, or 3 other models trained differently to adjudicate the first one and vote on, is the first one correct? So you set up a voting situation, with again, models that were trained slightly differently, right? And that still doesn't get you to 100% because the voters could be wrong also. But you're getting much higher confidence that the answers you're getting from the first AI must have validity, right?
So how does this change? I mean, if someone that's in the industry is getting out of RIT tomorrow, or somewhere else, right? I know a lot of people that went to RIT also. So
me too. So
I know you did. I looked you up. That's excellent. If people are getting out of school tomorrow, they're not being trained in this. how do they catch up?
Great question. Yes, that's right. So nobody knows we're out of focus. So here's the thing. We just had 2 meetings in a row at RIT. I'm on the board at RIT, and about this very topic. The very topic is, what do you do with ChatGPT and large language models with students? Because are students going to use them to cheat? Well, here's my answer. Not every professor agrees, right? But I think a lot at RIT, they're moving in this direction, which is the following. When students get out of school, they will be expected to be masters of large language models and generative AI at a minimum, if not broader AI, but certainly masters of that almost in any field that they're in, business, right? Marketing, sales, engineering, etc. So if you somehow think, oh, I'm going to tell them not to use this, I'm going to tell them don't cheat, I'm going to tell them, are you crazy? The kids are going to use it. They used it the day it came out. Before that, they used Chegg. So just everybody stop, right? So what we can do is say, let's just incorporate it into all our lessons and make sure that when you graduate here, you are an expert at prompting. You understand what embedding is. Embedding is a way to take a large language model and force it sort of to respond only to your data, like your customer support data or something like that, right? And I'll give you an example, right? When calculators came out, teachers were up in arms for years that, oh, people are just going to use calculators at home. They're not going to learn to do long division. Let me give you a hint. When's the last time you did long division by hand? Years. 4th grade. Who knows? It turns out doing long division by hand is not a necessary skill to be successful in this world. Now, some people are going to listen and they're going to say, well, it's the brain. Great. Teach people in 4th grade, but after that, they're never going to do it. When you graduate from any college from this May forward, it's expected that when you walk in, you know how to prompt, you understand generative AI and large language models at a minimum. And that's just a tool in your toolkit, just as much as a calculator and Excel is and Word is, right? And if you don't know how to do that, why would I hire you? People in marketing today that used to write blog posts, right, from scratch, are now writing blog posts by prompting AI to write the blog post in like 10 seconds, 20 seconds, and then editing it in a few minutes, and then it's out. So where they used to spend maybe a day from a blank screen getting a blog post done, they now spend 10 minutes, making them 100 times more brain power than they had walking in, right? So why would I hire anyone who has 100 times less brain power than the next person? So everybody better be trained on this. These are the tools we're going to use going forward, and you better be the master of them.
This may be a bit philosophical, but do you see the use of AI as changing human capabilities in the relatively near future?
Sure.
Or, if you want to go out 1,000 years, assuming that we're still around?
Sure. But all automation has. The wheel arrived, and all these big, huge guys that used to carry stuff up the hills, food, whatever it was, no longer had to do it because you had wheels, and ultimately you had horses that could pull these carts that could carry immense amounts of things. And so the wheel changed humanity. Fire changed humanity. The calculator changed humanity. Frankly, Excel really changed humanity, especially in finance, right? We all use it. And if you look at Excel as a math model, Excel, period, solved math, except very, very extravagant math, scientific math, but mostly solved math. We never have to do math again. There's a machine that does it. Okay? You're not expected to do the math. It would be bad. A large language model solves language. That's all. And isn't that great? It solves language. Now people say, yes, but I can ask it a question and it gives me an answer. So did Google. It's just better at it. We've had answers from Google for 25 years, right? We said, oh, Google's going to make us stupid. Well, Google certainly took away some skills that we no longer need. Think about direction finding, right? I mean, all of us use GPS now, so much so that regular places that we go to, we can't remember how to get to because we just push it on the computer, right? All of us. We're laughing.
I'm laughing because there are roads in my city that I just have no clue what the name of them are.
I don't need to.
Yeah.
Turn right, turn left.
Right.
Doesn't matter. But 20 years ago, we had to be thoughtful and memorize the turns and memorize what was on that corner and then describe at the yellow house, you turn left and then you go about 2 or 3 miles. And then when you see this brick building, you turn right. That's how we did it, right? We navigated by things we saw. Nobody knows how to do that anymore. And certainly our kids don't know how to do it at all. We use GPS. Even when we go to regular places, I use GPS, the traffic, this and that. Okay. So there are skills that are lost and they're not going to be used anymore. But that opens our mind up to do other things, right? So everyone in finance who thought their job was over when the spreadsheet came about, their job wasn't over. They became the master of the spreadsheet and they got to raise their skills on strategery in finance as opposed to adding and subtracting in finance. It turns out adding and subtracting was a dumb thing to waste a human on, but strategy was a really good thing to use humans for. And that's what we're going to be here, right? It's going to be the strategy of that blog post and the strategy of the next 50 and the editing of it and the thoughtfulness of it and the prompting of it, not writing the actual words. Who would write the actual words? And I know that's blasphemy as I sit here, but in a few years, it'll be, that's exactly what happened with spreadsheets.
I was sitting in a cube. Yeah, I love cubes, but I was sitting in a cube earlier this week, having a relatively philosophical discussion with a programmer who basically came to the conclusion that AI was going to eat his job, and that perhaps he was going to have to find a different way to pay his loans back. Is AI going to take the program? If everybody becomes 50% more productive and we get more stuff out, not just more lines of code, do we really need 50% more?
Yeah. Well, here's the thing, and here's what's happened, right? Remember, we've been getting more productive in coding for decades. If you go back to Fortran and COBOL and the tools we had, they weren't very good. And the debugging tools we had were awful. In fact, you ran them on cards, as you know, on punch cards, and you hope for the best, and they didn't work, and maybe you dropped the cards, and just go on, right? So we've actually been getting more productive every year, yet we need more coders every year. Now, why is that? Because when we get more productive, we produce more code and more features faster, but there's an unlimited need for features. It's unlimited, right? There's an infinite need for more features in everything that we do, and an infinite need by everyone from business customers to consumers to do more with software. Infinite. So no matter how fast you get, it will never be fast enough. Look, we've taken more than a decade, and most people aren't there, to move from waterfall to agile. 2 decades, maybe waterfall to agile, and then finally agile to DevOps in some firms, right? And, a real DevOps shop, you might do more than 4 releases a day. You could do hundreds, thousands of releases a day. Okay. Well, think of how good you had to be to get there and how productive everybody had to be and how coordinated everybody had to be. Well, now we're going to make that 10 times better. Okay, great. I'm going to get 10 times more features out in the same amount of time, or the same features out in a 10th of the amount of time. Pick your poison, right? So I think because there's an infinite need for additional features and additional functionality, that we're not going to run out of coders. Now, a lot of people will do less coding and more strategy around the code. How am I going to solve this problem? What are the ways to solve this problem, right? And that's probably good anyway. We all know that, the coders, developers, et cetera, often kind of shoot from the hip because it's urgent. Start coding. And what they should have done is gone to the whiteboard with 5 other people and strategize how they're going to solve this problem. So they code right away. They do something. They break 5 other things. We all do this. I mean, it's no blame, right? So I think it's going to make us more strategic and more thoughtful, because when we finally go to code, the coding part's going to be 10 minutes. It's the strategery of getting there that's going to be the most important.
That assumes, though, that we do end up with something, that actually handles the testing. Because very frankly, we all know where, if we just took the big blocks, right, where the bottleneck is. Because it'll pile up there. And I can make 100,000 things and pile them up. But by the time I get them tested and put in production, how many thousands of those are actually going to be worthwhile anymore?
So unit testing is getting automated pretty well with AI today. And that's because it's sort of an unknown block, if you will. Let's say it's a small subsystem. It's a little Kubernetes, and it's got an API that's well defined, right? That's testable today. AI will write those tests. Why? I have a defined API. Done. It's when you get to end that you really don't know, because nobody's actually put on paper in a formal way everything the system should do or shouldn't do, right? Now, you can do that with an API. Here's the Swagger spec. Done. It's very hard to do with a large end-to-end system that's tied to 16 back-end systems, right? Payments and databases, and, whatever, manufacturing, shipping. So that's harder. But again, I think the methods that we're using to solve this, which include two things, something called an AI blueprint, broadly developing tests way outside of your test cases, because that's where the bugs are found. People find bugs in things we don't test. So we better go test the things that we weren't going to test, right? But if we can already, the AIQ system, Appvance system, will generate thousands of scripts and run them, in well under an hour that you could not have generated over 6 months. Couldn't have done it. And they're valid because they're what we call a trained system. So there's an AI training session that takes place where a QA engineer is in charge of the AI workbench and trains the system what to do and what not to do generically, right? Not just this one thing, but generically a user could do these things, but would never do these things. Like a user wouldn't log out on every page, and we don't care if they do. So don't test that, right? That's an example. So with this trained system, which came out in 2017, it's been out for a while, that has worked exceptionally well because it will generate every possible reasonable flow from login all the way to the end, all data driven, fill out all the forms, and do so incredibly accurately. And you look at these 5,000 scripts that'll write an hour or something, you'll go, this is unbelievable. I've never seen anything like it, except that millions and millions of those have been written over the last 5 or 6 years because the system's been out. Most people don't know it's there, but it is. It's been there and it's mature. So fascinating technology. And now we're closing the gap on what about the test cases that business analyst wants us to run, whether they're right or wrong, they insist, and they're data driven in this way. And that's the final gap that we're closing, is getting those exact to what they said they want in terms of how they run, where they run, what the outcomes are, what the environment is, et cetera.
Kevin Surace, this has been absolutely fantastic. If you woke up tomorrow morning, somebody handed you your caffeinated beverage of choice, a magic wand, and said that you could magically get rid of 2 myths on how AI is going to influence the software development world, what would those 2 myths be and why?
Sure. Well, there's kind of 2 sides to that. The first myth has been around for the last year, which is, we can just use Gen AI, ChatGPT, to write our tests. Anyone who's tried that found out, as I talked about earlier, no, you can't. and I could spend hours on teaching people why that doesn't work. It makes some interesting suggestions, most of which aren't correct. So that's a challenge. And in fact, there's companies out there, startups that I know, that went out and attempted to raise, I don't know if anyone got it, but they attempted to raise money on that. They put a front end on GPT and they said, look, it wrote these 5 steps all by itself to buy something from the Apple store, let's say. It turns out that's about the only use case it can write, and it can only do 5 steps. And even those 5 steps are slightly broken and still need data and take about 4 minutes to fix, right? Which I could record that use case in 40 seconds on what's called Test Designer in Appvance, right? So it makes no sense. But VCs don't understand this. So VCs aren't as technical on software testing as one might be, right? So it's easy to fool people. But I like to call that a parlor trick. And I do the parlor trick. I'll say, let me show you this. And they go, wow. I said, and that's the only time it works. It does know how to buy something in this particular store from this point to this point. Still can't fill out the forms again, but that's a different story. But nevertheless, it'll write a reasonable Selenium script to do that. So the first thing I'd say, everybody get out of that. QA is not that easy. And those deep in it, no, it's not that easy, right? It's actually really, really hard. And so that's number one. And number two, the other side of that myth is, AI will never be able to do what I do as a Selenium writer or a test engineer I'm sorry, yes, it will. Now, but here's the good news. If you're a really great QA engineer, quality engineer, test engineer, your job shouldn't be about writing Selenium scripts all day. That was never your job. Your job was driving quality into the system. And when we start coding 2 times, 4 times, 10 times faster, we're going to need a lot of people thinking about what does the quality system mean? What are the outcomes? And when AI finds 110 bugs on its first run, which of those do I care about? Which of those are most likely to impact users? How do I prioritize those? So just like in finance, we took people from adding and subtracting in ledger books to being strategic. We're going to take our QA people, those that want to, and make them strategic. Are there people that I've met that go, you are not bringing that AI in here? I'm a Selenium scripter. Yes, but they had forgotten their job wasn't Selenium scripting. Their job was to drive quality engineer. They just got stuck in Selenium scripting. So Selenium scripting, that kind of stuff, that's going to be gone in short order, weeks, months, years, not decades.
So that's one.
Well, I did 2 sides, right?
Oh, okay.
Because I said there's really 2 and they're 180 degrees apart, right? One is everybody thinks it's going to work like that. It doesn't. It's a parlor trick. Parlor tricks are cool.
Okay.
And the other side is it's actually going to happen, but not as easily as everybody thinks.
I've always felt that anybody says, I will never use this tool is usually a sign that they need to find a different profession.
Yeah, I think that's right. That's right.
Kevin, how would people continue the conversation? How would they find out about you? How would they find out about Appvance?
Yep. Appvance.ai is the web address for Appvance. Easy to find. appvance.ai. My personal website, kevinsurace.com. You can find my LinkedIn there if you want to direct message me on LinkedIn. I answer all the kind requests.
Only the kind ones.
Only the kind I won't answer if you scream at me and say, you're being mean to something. I'm not trying to be mean to anything. I'm trying to be a futurist and trying to look 1, 2, 3, 4, 5 years in the future and saying this is where things are headed. Right.
That's fair. At this point, I open up the platform for you to promote anything that you like. This has been educational, philosophical, all the things that I was sort of hoping for a Friday afternoon. So the platform's yours to promote anything that you would like.
Oh. Look, I think, I'm a keynote speaker. That's, I spend a good portion of my days doing that. I did 3 keynotes, this week. I'm CTO at Appvance and, we have absolutely every intention of achieving this goal of AI finding our bugs. It's been something we've worked on for now 11 years. It's a very hard proposition. It gets better all the time. And so, if you don't know anything about it, you should go check it out. And, you can fill out forms and get demos and all those kinds of things.
Super. Thank you again. This is Kevin Surace. This has been absolutely fantastic. Thank you for spending the time with us.
Thank you for having me, Tom. Appreciate it.
In Reread Saturday News, this week we begin the read of Actionable Agile Metrics Volume 2, Advanced Topics and Predictability by Daniel S. Vacani in earnest, covering chapters 1 and 2. These 2 chapters provide a statistical cautionary tale and then go on to define variability. The definition of variability is the foundation that much of Actionable Agile Metrics Volume 2 is based on. Remember, buy a copy, link in the show notes, read along. In the next software process and measurement cast number 787, we continue into the minefield of why starting everything you are asked to do is problematic. Framing the discussion is a text from a friend of the cast, which highlights the minefield of starting everything. We also have a visit from Susan Prente and her Not a Scrumdimentalist column. If process improvement is a never-ending journey, why do so many people ask, are we there yet?